Howdy, calculates. It's been a while since you've seen my beautiful face. Hopefully, Calculus will join us in a little while. So, we've already started talking about integrals and area under the curve. And so now we're going to start seeing more of the numbers that are above and below on our integration symbol. And that does nothing more than tell us the boundaries that we're finding the area between. So this is our formula for finding area, is to simply integrate. This is not really intended to look like a capital F, it's a lowercase. And so now we're going to talk about some properties of definite integrals. Indefinite means I wouldn't have these numbers at the top and bottom. That's indefinite, meaning it goes on forever. But definite integrals have the boundaries. Okay, so if I have a function and it's defined at a particular point, then the area of that function, between that function and the curve, from A to A, is 0. Here's why. Let's say I have my curve of f of x, and I'm trying to find the area at A. Clearly, it has no width, so I can't find the area of it, so it's simply defined as being, 0. And if I find the area underneath my curve, between my curve, and keep in mind that this notation at the end tells me which axis I must be hitting. Yeah, we've talked about that in class in terms of if my graph, and you had one the other day where the shaded area was here, and so when I look at that, my area doesn't touch the x-axis, it touches the y-axis. So on this one, I would want to take the integral with respect to y, because that's the axis that it's touching. Most of your problems actually have touched, the area has been under the curve, like over here where I'm drawing right now. And so therefore it's touched the x-axis, which is why we've been doing dx. Okay, so at any rate, if I find the area between the curve and the x-axis from A to B, and if I mess up, let's say, and I put those letters in the wrong order, then what happens is it'll make my area actually be negative. And I think of this as somehow I'm finding, this is how I rationalize it in this crazy head here, is that I'm finding the area backwards. I'm doing it from right to left, as opposed to here, it's from left. And you can see that A is on the left in the interval and then to right. So if you do it backwards, you'll get a negative answer. And on the next piece, so let's say I have these intervals from A to B to C, and I find the area between A to B, again, with respect to x. And let's say that C happens to be somewhere in the middle of this interval. So I have A and C and B. And I want to find the area from A to B, but currently what I know is the area from A to C and the area, so I would know whatever the area was up here. So if I have a particular function, let's say, kind of ran out of room. And I know that area from A to C. And then I also happen to know the area from C to B. It should make sense then that I could add those two areas to get the entire area from A to B. So I did the A to C part, that's all of this.